Okay, example 6, we're going to find the limit. Okay, if the limit does not exist, we'll explain why. We're going to use a graphical approach here. So looking at the limit, we've got 4 minus x, x squared minus 16 as x approaches 4 from the right. Okay, so this function, we could graph it definitely, but let's see if that simplifies, because if it simplifies, then it's going to be easier to graph. So let's look at the limit. Let's make this x, negative x plus 4 all over x minus 4 times x plus 4, that factors, as x approaches 4 from the right. Then the numerator, I can factor out a negative 1. So then I have x minus 4 all over x minus 4 times x plus 4 as x approaches 4 from the right. Then I think you can see here this reduces. So we have the limit of negative 1 all over x plus 4 as x approaches 4 from the right. Okay, so this limit, because we can do direct substitution here, this limit should definitely be equal to negative 1 over 8. But they want us to use a graphical approach. So if this was a test question, I'd want you to graph this. Alright, so let's take a look at this function. Okay, so you have to think about the parent function of this function. So the parent function is just the simplest form of this function. So let's look at the function y equals 1 over x. That would be the reciprocal function. Okay, so the reciprocal function would look like this. Okay, then let's do transformations. The next step in this function, equals y sub 2, would be negative 1 over x. So that would make it look like this. Okay, so this one was in red, the second one was in blue, the third transformation, doing this light blue, this is going to shift the one that's in darker blue over to the left 4 units. So 1, 2, 3, 4. And 1, 2, 3, 4. The vertical asymptote will be right here. And then this graph is going to look like this. Okay, so the light blue is the final graph here, and I just did transformations to illustrate that. And if we plug in 4, should be 1, 2, 3, 4. Right here, this point here should be 4 comma negative 20. Okay. Alright, let's look at the last example here. Same thing. We want to solve this from a graphical approach. There's no way to really simplify that anymore. So let's graph it. Okay, we know there's a relationship between y equals cosine of x and y sub 2 equals secant x. Let's graph cosine of x first, and then we will show you how it relates to secant of x. So cosine of x has a period of 2 pi. Starts up at 1, comes back down, and then comes back up again. So it's going to look something like this. Okay. Now the secant function is going to have vertical asymptotes everywhere the cosine function intersects the x-axis. And then the secant function will look like this in blue. Okay, and what we're looking at here, we want to look at the limit of the secant of x as x is approaching pi over 2. Well, let's look at one-sided limits. Look at the limit of secant of x as x approaches pi over 2 from the right. From the right, this is going to equal negative infinity. And then if we compare that with the limit of the secant function as x approaches pi over 2 from the left, that's going to equal positive infinity. Because these one-sided limits do not equal each other, this limit does not exist.